Hello everyone and welcome to today's presentation on network security. Today we want to discuss network security because networks are constantly under threat from malicious actors seeking to exploit vulnerabilities that we discussed in our previous lectures and compromise sensitive information. So network security is a critical concern for organizations of all sizes and industries. So it involves the practices and measures taken to protect computer networks from unauthorized access, use, disclosure, disruption, modification, or destruction. So this presentation will provide an overview of network security, including network architecture, the types of networks, network components, and network protocols. So we also delve into the world of intrusion detection and prevention systems, exploring the different types of intrusion detection systems and intrusion prevention systems, as well as the indication of system intrusion. Finally, we will discuss intrusion response, including also the application of control theory, the game theory, and fuzzy theory to develop effective intrusion response strategies. So by the end of this presentation, you have a comprehensive understanding of network security and intrusion response, and this will be equipped with the knowledge of tools necessary to protect your organization's computer networks from malicious threats. So we'll start by defining network security, and this one refers to the practices and measures taken to protect computer networks from unauthorized access, use, disclosure, disruption, modification, or destruction. So this includes ensuring the confidentiality, the integrity, and availability, which is the CIA trait that we discussed in our previous lectures, and you can go back and look at it. So this includes ensuring the confidentiality, the integrity, and the availability of data that is transmitted over the network. So network security is essential because it helps prevent unauthorized access to sensitive information, protects against data breaches, and ensures the smooth functioning of network infrastructure. Then also under network security, this involves protecting against unauthorized access, preventing malicious activities such as hacking and malware, ensuring the integrity of data transmitted over the network, and also it maintains the availability of network resources and services under the CIA trade that I explained earlier. So we move on to network architecture, and this one refers to the design and organization of a computer network, including the hardware, the software, and the communication protocols used. So we have so it involves the designing the network topology and infrastructure, selecting and configuring network devices such as routers and switches, implementing network protocols such as TCP, IP, and DNS. Then you can talk of ensuring network scalability, reliability, and performance. Then we have types of networks that we have. Here on the screen I have a local area network, then we have a wide area network, then we have what we call personal area network. And we're talking of personal area networking, it's saying that this is a network that connects devices within a limited area, typically within a few meters. Examples include Bluetooth and Wi-Fi direct. Then we can talk of local area network. This one is a network that connects devices within a limited geographical area, typically within a building. You can talk of here at campus, an office building. These examples include Ethernet and Wi-Fi technologies and are designed for high-speed communication. Then we move on to wide area networks. Here we are saying that a network that connects devices over a larger geographical area, typically spanning multiple cities or countries, right? examples include the internet, right? So they use various technologies, including leased lines, satellite links, and the internet to enable communication between geographical dispersed. Then we also need to move on to before we discuss about security, we have to discuss the basic principles of networking, we discussed the types of network, the network architecture. Now moving on to network components and protocols. And network components include devices such as routers. And routers, these are devices that connect multiple networks and route traffic between them. Routers use routing protocols such as OSPF and BGP to determine the best path of data transmission. We talk of switches. Here, these are devices that connect multiple devices within a network and forward data packets. So switches use MAC addresses to forward data packets. We can talk of firewalls. This one is for security. Devices or software that control incoming and outgoing network traffic based on predetermined security rules. So firewalls can be hardware based or software based. We will discuss about this in our next lectures. Then we can talk of servers. Servers, these are devices that provide services such as hosting websites, email, or file sharing. Servers can be dedicated or virtual, right? Then these components work together to facilitate network communication by routing data packets, establishing connection, and ensuring reliable transmission. So these components work together. A router works with a switch, and the firewalls and servers, this work together. So we cannot use a switch alone, we cannot use a router alone, we can also not use the firewalls maybe without servers. This is what we are saying. Then we move on to network protocols. We have network protocols, and this one define the rules and standards for data formatting, addressing, routing, and error detection. So we have TCP, and maybe we can talk of UDP. For now, we're going to discuss TCP, which is Transmission Control Protocol, Internet Protocol. This one is a protocol that enables reliable, error-checked data transfer between devices. So TCP uses a three-way handshake to establish communication. If you want to know more about TCP/IP, you can go back to my lectures on data communication and networks. This one is under data communication and networks, not cybersecurity. You see how the TCP works. The three-way handshake is explained there. Then we can talk of UDP, maybe a protocol that provides best effort delivery of data packets between devices. UDP is commonly used for real-time applications such as video streaming. Then I want to move on to intrusion detection systems and prevention systems. So we need to define an intrusion. So according to my definition, an intrusion refers to an unauthorized access, use, disclosure, disruption, modification, or of computer network resources. This is how I define an intrusion. Then we move on to intrusion detection systems and prevention systems. These are security technologies designed to identify and respond to network intrusion and attacks. So in an intrusion detection system, monitors network traffic for signs of unauthorized access or malicious activities. And then an intrusion detection system can be network based or host based. So this one monitors network traffic and system for suspicious activities or non-attack patterns. So it generates alerts or notifications when it detects potential security breaches, but does not actively block or prevent attacks. Then intrusion prevention systems not only detect but also prevent intrusions by blocking malicious traffic. So IPS can be network burst or also can be host burst. So this one goes a step further by not only detecting intrusion but also actively preventing or mitigating them. It can automatically take actions such as blocking traffic, dropping packets, or reconfiguring firewall rules to stop malicious activities in real time. So in short, we are saying that IDS focuses on detection while IPS focuses on prevention. IDS provides alerts and notification while IPS take action to block malicious traffic. Here we are just explaining an intrusion detection system. This is used to monitor and protect networks or systems for malicious activities. So intrusion detection systems are used to monitor network traffic and also referred to as a packet sniffer, which intercepts packets traveling along various communication mediums and protocols, usually the TCP/IP. This is a protocol that we explained. Then also need to explain how this IDS works, right? So this one works by analyzing network traffic and comparing it to a database of known threats. IDS can use various detection methods, including signature burst, anomaly detection, and protocol anomaly detection. So an IDS checks for suspicious activities. One, it notifies the administrator about intrusion immediately. It gathers and analyzes information from within a computer or a network to identify the possible violation of security policy, including unauthorized access as well as misuse. It analyzes packets after they are captured. It evaluates a suspected intrusion once it has taken place and signals an alarm. This is an example how an intrusion detection system is placed in a network. We can see here there is an internet. It's between a router and a demilitarized zone. Then there's also an intrusion detection between DMZ and the intranet. Then there is a user. So this is an example of how an IDS is placed in a network. Then also need to move on to the purpose of an intrusion detection system. This one we explained it. Maybe to repeat, the main purpose of intrusion detection systems, here we are talking of intrusion detection, not prevention, that they not only prevent intrusions but also alert the administrator immediately when the attacker is still going on. So the administrator could identify methods and techniques being used by the intruder and also the source of attack. So this one is used to monitor and protect networks or systems for malicious activities, to alert security personnel about intrusions. Intrusion detection systems are highly useful. So they're also used to monitor network traffic, as explained earlier, is also referred to as a packet sniffer. We also need to explain how IDS works. So these have sensors to detect signatures of known threats, and some advanced IDS systems have behavioral activity detection to determine malicious behavior. So even if signatures don't match, this activity detection system can alert administrators about possible attacks. So if the signature matches, then it moves to the next step, or the connections are cut down from the IP source. So the packet is dropped and the alarm notifies the admin and the packet can be dropped. Then once the signature is matched, then sensors pass on anomaly detection, whether the received packet or request matches or not. If the packet passes the anomaly stage, then static protocol analysis is done. After that, through switch, the packets are passed onto the network. If anything mismatches again, the connections are cut down from that IP source, the packet is dropped, and the alarm notifies the admin and the packet can be dropped. Here we have ways to detect an intrusion. We have a signature detection, we have anomaly detection, and also have protocol anomaly detection. So on signature recognition, we are saying that the IDS compare network traffic to a database of non-threat signatures. So this one is also known as malicious detection. It tries to identify events that indicate an abuse of a system by creating models of intrusion. So incoming events are compared with intrusion models to make a detection decision. While creating signatures, the model must detect an attack without disturbing the normal traffic on the system. Right. So the simplest form of signature recognition uses simple pattern matching to compare the network packets against binary signatures of known attacks. So a binary signature may be defined for a specific portion of the packet, such as the TCP flags. There is a possibility that other packets that match might represent the signature, triggering bogus signals. We move on to anomaly detection, and here anomaly detection is otherwise called not use detection. The model consists of a database of anomalies, right? So any event that is identified with the database is considered an anomaly. Any deviation from the normal use is labeled an attack. So creating a model of normal use is the most difficult task in creating an anomaly detector. So in reality, there is a less variation in network traffic and too many statistical variations, making these models imprecise. Some events labeled as anomalies might only be irregularities in network usage. So we are saying that IDS monitor network traffic for unusual patterns or behavior. For example, IDS may detect unusual login attempts from an unknown IP address. Anomaly detection is reportedly effective in detecting unknown threats and providing real-time alerts. So it may generate false positives, one of the disadvantages, and requires tuning and configuration. Then on protocol anomaly detection, this one is based on the anomalies specific to a protocol. So it identifies the TCP/IP protocol specific flaws in the network. So protocols are created with the specifications known as RFCs for detecting proper use and communication. So the pace at which the malicious signature attacker is growing is incredibly fast. So protocol anomaly detection systems are easier to use because they require no signature updates. So what we are saying is that IDS monitor network traffic for protocol deviation. For instance, an IDS may detect unusual DNS queries. Protocol anomaly detection is said to detect protocol-based attacks and provide detailed analysis. However, it requires protocol expertise and may also generate false positives. So we discussed the three ways to detect intrusions. We discussed the signature-based. In summary, we say that it compares network traffic to a database of non-threat signatures. For instance, an IDS may detect a malware signature in incoming network. Signature detection is said to have higher detection accuracy and low false positive rate. However, it requires a frequent signature updates and may not detect unknown threats. So on signature based, we are dealing with signatures. Then on anomaly detection, we say that this one monitor network traffic for unusual patterns. So this one works with anomalies. Then also need to move on to protocol anomaly. This one is said to detect protocol based attacks, right? Then also need to move to types of intrusion detection systems. So here we have a network-based intrusion detection. Then we have host-based intrusion detection. Then we have log file monitoring intrusion detection. So here on network burst intrusion, we are saying that this one monitors network traffic from the word itself, network burst. Here we monitors network traffic. So network intrusion detection systems provide real-time alerts and can detect network burst attacks. From its name, then according to experts, this one may generate false positives and require network expertise. Then there is host burst intrusion detection systems. This one monitors individual host activity. So this provides detailed analysis and can detect host burst attacks. However, this one may also generate false positives and require host expertise. Then log file monitoring. This one analyzes log files for security threats. Log file monitoring provides detailed analysis and can detect log burst attacks. Then we have file integrity checking. This one monitors file changes. File integrity checking provides real-time alerts and can detect file burst attacks. So you are saying that for network, this one is for network. This monitors network. For host burst, this one monitors individual host activity. Then for log file monitoring, this one analyzes log files for security threats. Then for file integrity, this one monitors file changes. These are the types of intrusion detection that we have: network burst, host burst, log file, and then file integrity checking. This one, then and also on file integrity checking, these mechanisms check for Trojan horses or files that have otherwise been modified, indicating an intruder has already been there. For example, with tripwire. Then also we need to look at system integrity verifiers. This one monitors systems files to determine whether an intruder has changed the files. So although they have limited functionality, integrity monitors can add an additional layer of protection to other forms of intrusion detection. Then we move on to the indication of system intrusion. One, we have short or incomplete logs. These are logs that are incomplete or missing. For example, a sudden stop in log entries indicating a potential system crash or shutdown. So missing log files or directories, which could indicate, they can also indicate a malicious actor trying to cover their threats, their tracks. Then there is unusual graphic displays. This one is, these are unusual system behaviors or graphics. So these are unexpected pop-ups or alerts which could indicate malware or unauthorized access. There's also unusual system tray icons or taskbar notifications which could indicate a malicious program running in the background. So we have unusually slow system performance. These system slowdowns or crashes, for example, frequent system crashes or blue screens. These indicate potential hardware or software issues. So system startup or shutdown times, which could indicate malware or resource-intensive programs running in the background. There is also modification to system software and configuration files. So these are unauthorized changes to system files. For instance, we can talk of unexpected changes to system registry settings or configuration files. Then new or unknown system services or drivers installed without authorization. Then we can talk of missing logs or logs with incorrect permissions or ownership. These log files that are missing or have incorrect permissions, for example, log files with incorrect permissions or ownership, indicating potential. This one indicates potential unauthorized access. Missing log files or directories, which could indicate a malicious actor trying to cover their tracks. Then there's also what we call system crashes or reboots. This one, this is frequent system crashes or reboots right? For example, we can talk of blue screens indicating these are potential hardware or software issues, unexpected system reboots or shutdowns, which could indicate malware on unauthorized access. Then there is gaps in the system accounting. These are missing or incomplete system accounting records. For example, missing or incomplete system login or logout results records, inconsistent or missing system resources usage records. Then the last one, we can talk of unusual unfamiliar processes. These are unfamiliar system processes. For instance, unknown or unfamiliar system services or drivers running in the background. Then unexpected system processes consuming excessive system resources. Then the other that we can add that are not on the screen, we can talk of unusual network activity, unusual network traffic or connection. For example, we can talk unexpected incoming or outgoing network connections, unusual network traffic patterns or protocols. Then there are alerts from intrusion detection systems or intrusion prevention systems. These are alerts from intrusion detection system. For instance, alerts from these systems indicating potential security threats or vulnerabilities, alerts from these systems indicating suspicious network activities or systems behavior. Then now we want to move on to network intrusion. I think we discussed this, but maybe as a summary, as a summary of indication of intrusion. Sudden increase in bandwidth consumption is an indication of intrusion. Repeated probes of the available services on your machines. There's connection requests from IPs other than those in the network ranges are an indication that an authenticated user or intruder is attempting to connect to the network. You can also identify repeated attempts to log in from remote machines. Then arbitrary log data in log files indicates attempts of denial of service attacks, the bandwidth consumptions, then distributed denial of service attacks. Then we'll move on to intrusion response. On intrusion response, the function of intrusion detection system without a timely response against intrusion and threats will be largely limited, even they can detect attacks and generate alarms. So a comprehensive security solution usually has a timely countermeasure against intrusions. Then we have different response approach. We have passive alerting and manual response. This one is a passive intrusion detection system, notify or detect attacks instead of stopping them entirely. We have active response. This one, active intrusion detection systems analyze and monitor host audit data or network traffic data on the fly. Then there is decision analysis, apply automated reasoning and decision-making theory in the human-mediated or automatic response. Then we can talk of some theories. Here I want to explain the control theory, the game theory, the first theory in the context of intrusion response. So when you're talking of control theory, this is a branch of mathematics that deal with control and regulation of systems. In the context of intrusion response, control theory can be applied to develop strategies for controlling and mitigating the effects of an intrusion. So control theory involves one, we talk of modeling. These are developing mathematical models of the system and the intrusion. Two, there is analysis. This is analyzing the models to understand the behavior of the system and the intrusion. Then there is control, developing control strategies to mitigate the effects of the intrusion. Then we can talk of this one can be used to develop intrusion response strategies that take into account the dynamics of the system and the intrusion. Then on game theory, this is a branch of mathematics as well that deals with the study of strategic decision making. So in the context of intrusion response, game theory can be applied to develop strategies for responding to intrusion that take into account the potential actions and reactions of the attacker. So game theory involves modeling. This is developing mathematical models of the intrusion and the potential response. Analysis, analyzing the models to understand the potential outcomes of different response strategies. Then there is optimization. This is developing optimal response strategies that take into account the potential action and reaction of the attacker. So this one can be used to develop intrusion response strategies that take into account the potential actions and reactions of the attacker. Then we can talk of fuzzy theory. This was also known as the fuzzy logic. Is a branch of mathematics that deals with the study of fuzzy sets or fuzzy logic. In the context of intrusion response, fuzzy theory can be applied to develop strategies for responding to intrusions that take into account the uncertainty and the ambiguity of the situation. So this one involves fuzzification, which is converting crispy data into fuzzy data. Then there is inference, using fuzzy rules to make inferences about the situation. Then defuzzification, converting fuzzy data into crispy data. So this one theory can be used to develop intrusion response strategies that take into account the uncertainty and the ambiguity of the situation. So also need to talk about the application of these to intrusion response. So control theory, game theory, and fuzz theory can be applied to intrusion response in various ways that include: 1. Intrusion detection, response, and uncertain management. On response, this one can be used to control theory. This one is for detection. Can be used to develop intrusion detection systems that take into account the dynamics of the system. Then the game theory can be used for intrusion response, to develop intrusion response strategies that take into account the potential action and the reactions of the attacker. Then the uncertain management, this is the first theory, that can be used to develop intrusion response strategies that take into account the uncertainty and the ambiguity of the situation. So by applying control theory, game theory, and the other theory to intrusion response, organizations can develop more effective and efficient intrusion response strategies. Thank you for listening to this presentation. This marks the end of our presentation. Thank you.